Switzerland, the home of chocolate, watches, dodgy banks, and artificial black holes that could end humanity? Well, no, not exactly. But in 2008, that is what every Facebook warrior and Reddit demigod thought, even though the vast majority of them couldn't tell you what a particle even is. Now the year is 2022, and most of us are still here despite the Large Hadron Collider having been turned on many times, but all of a sudden the keyboard particle physicists are at it again. Could this be it finally? Will Switzerland at long last just fuck off into another dimension, a separate reality? Is it even Christian to end the life of a proton? If light is so fast, why has it never won gold at the Olympics? Will Europe time travel to 2012 to stop Disney from buying Lucasfilm and ruining a franchise? All valid questions CERN had to answer before launching light-speed particles at each other to see their guts. But before we get to that, what even is the Large Hadron Collider? And what does it do? To answer that, here's PS1 Hagrid.
Hey, you bet I know what that is. The Large Hadron Collider is named as such because number 1 it is large, number 2, it accelerates hadrons, and number 3, it collides them together to make some pretty spooky shit that no one really understands. But what's a hadron? A hadron is just some fancy bullshit name particle physicists use to refer to particles like protons that are made up of smaller particles called quarks. So how does it work? We accelerate two particle beams separately, giving them a total energy of up to 6.5 teraelectronvolts. Then we say fuck it and make them hit each other head-on to create a total collision energy of 13 teraelectronvolts and see what happens. We then rely on the 7 detectors around the circuit that observe specific phenomena. This gives scientists a good idea of the composition of the subatomic world and what laws govern it. But nobody cares about that. Tell me about the black holes.
Essentially, the LHC lets us test theories and models of the universe on a subatomic level, specifically the Standard Model and the Higgsless Model. Some experiments that have been run already have proven the existence of the Higgs boson, exploring the existence of a theoretical group of subatomic particles called supersymmetric partners. Are there other dimensions, as string theory would suggest? And investigating the dark matter, which accounts for over a quarter of the universe's mass. There is still much more to explore, such as investigating whether the electroweak and strong nuclear force are separate manifestations of the same force. Why is gravity weak as fuck compared to the other three forces? Are there other quark flavors? What are the properties of quark, gluon, plasma? And why is there blatant and obvious violations of matter-antimatter symmetry? Okay, now that we all know why we have a particle collider running underneath an entire city, glossing past how it was built, how it really works, the fact that it cost 7.5 billion euros to build and has been upgraded many times since, let's look at the dangers, particularly why miniature artificial black holes were a real concern for one or two physicists and countless 40-year-old elementary graduates with a Reddit account. The first danger was cosmic rays. Honestly, this one is stupid, so I'll summarize it in less than 30 seconds. Basically, people had a problem with the accelerator producing cosmic rays, but they didn't stop to think for 1 second that cosmic rays come from every part of space around us and bombard the Earth non-stop for the last 4 billion years. So in the end, that was no concern for CERN. Strangelets are weird, and to be honest, I'm pretty past them at this point. So here's my friend, Dr. Yuri, to explain them. Thank you, Yuri. I'm really glad I listened to that. I'll be honest, I had never heard of vacuum bubbles before writing the script for this video, but the theory is both interesting and seemingly complete bollocks. But hey, I'm not a qualified particle physicist. Essentially, the theory goes that the universe we exist in is unstable and LHC perturbations could send the universe into a stable state called a vacuum bubble, rendering humanity non-existent. But going back to the cosmic rays thing, it hasn't been observed in the universe so far, so it's incredibly unlikely that they'll be produced in the LHC. Once again, cosmic rays have not created proton-eating particles with a single magnetic charge, north or south, so why would LHC? At this point, people are just making up shit for attention. Now for the main event, the cherry on the cake, big black holes. Actually, even small, like really small black holes. You see, the LHC is nowhere near the size of the Sun, and it can't just bust out console commands to spawn an everyday sized black hole. It can only make little ones. But that is just as scary because these little black holes could pull in more and more matter exponentially, right? Well, this guy thinks so.
Hi. I'm seeing a lot of videos and posts and stuff on social media apps about how CERN will do something with the particle reactor on July 5th, something with dark matter and shifting timelines, and a lot of people will die. I have had so much death in my family this year. Can someone explain to me that this isn't going to happen so I can sleep?
If you read the replies, people are just mind blown, and understandably so. But where did this Reddit user hear about this shit? Why, from a video, of course. Actually, this entire comment is just a trip. Some shit about injecting and suicide, and of course he's done 3 shots at this point. I'm getting some Jonestown vibes, but that's just me. Here's the thing. The LHC can theoretically create miniature black holes if string theory is to be believed, but these black holes would only contain the mass of a few protons. Why is that relevant? Well, assume the Earth is replaced by a black hole of the same mass. It would not suck the moon in. In fact, the moon wouldn't even feel much of a difference because the gravitational pull of the black hole would not change. The same applies to our mini black hole. It just wouldn't have the gravitational pull to gobble up the world atom by atom. But here's where things get really interesting. Remember how we were smashing these protons together at 99.99% the speed of light? Well, the resultant black hole doesn't just lose this momentum. Our tiny black hole flies through the Earth and out the other side, or up through Switzerland and into space that way. That's because the space between atoms is so empty, the probability of the mini black hole hitting anything, slowing down completely and eating up mass is infinitely small. Of course, this theory operates on the basis that Stephen Hawking was wrong. Hawking radiation is the loss of energy radiated away by a black hole. Essentially, a black hole evaporates slowly, or almost instantly if you have a particle-sized black hole. Black holes would pop out of existence as soon as they pop in, posing no threat to anyone at all.